Alright, hey, my name is Ali. I'm a sophomore in the GSCI1000E class this fall 2021 semester. Tonight I'm going to be exploring coastal infrastructure and sea level rise, which are directly related to climate change. So this mainly relates to Module B, Unit 7, Climate Realism, and Module E, Unit 19, Solar Futures. However, I feel that this can really be tied in with any module and any unit. So my thesis states, coastal infrastructure must implement anti-flooding operations to adapt to sea level rises as a result of climate change. So to start off this presentation, I'm just gonna set some context as to why sea level rise occurs before I dive into how we as humans are impacted by this environmental change. So to start off, we actually directly contribute to sea level rise by burning fossil fuels and having high carbon emissions from, let's say, our vehicles. So pretty much as we contribute to climate change by heating up the earth, of course, as ice heats up, it melts. So this would mean that climate change consequently melts our glaciers and ice sheets, increasing the amount of water in the ocean. So our Arctic biome they're pretty massive. So thinking about the long-term implications of ice melting on a global scale, our oceans could rise to a considerable degree. And the second reason for sea level rise is just the volume of our water expanding as the temperature of the water increases. So this is also one of the implications of global warming. According to climate.gov, our sea level has risen 8 to 9 inches since 1880, and this trend is expected to continue and quicken as time goes on. Now that we've set that in context, obviously the impact this has on humans starts with the coastal communities. So those that live by bodies of water will be at risk of flooding as our oceans become filled with more water. So I have an amateur model of sea level rise, and as you can see, I have this plastic bowl filled with water with plenty of miniature homes in this suburban utopia along the shoreline, and this represents those who live in coastal communities, and the tape represents the seawall protecting them. So as ice melts, water volume increases, resulting in those on the coast being flooded with water. So as you can see, our seawall made of Scotch tape isn't very effective, and this is actually the case in real life as well. Of course, this flooding is a gradual change, as is climate change, but you can see why this is concerning. So if we look at a first-hand account of flooding caused by rain in Zhengzhou, China, we can see how devastating floods can be, as the death toll reached up to 99 people. So if we look at the location of Zhengzhou on a map, we can see that this area is bordering the Yellow Sea. Now imagine the extreme rain with already high sea levels. The water would be even more damaging to our infrastructure, and we need to adopt methods to prevent flooding as a safety precaution. So more first-hand accounts regarding a storm in Colorado show how difficult it is for our current safety procedures to save everyone during times of crisis due to the sheer amount of systems falling apart during floods. It is incredibly difficult to help everybody. The volume of storm-related calls and requests for assistance are overwhelming, and the moral of the story is that prevention is much more effective than maintenance. If we can help to prevent the problem before it happens, we'll have to worry a lot less about dealing with it in the moment. So now that we've established why it's important that we acknowledge the issue of sea level rise and update our coastal infrastructure, I'm gonna dive into how we can go about doing this in the future. So the sources I'm gonna reference are all peer-reviewed primary reports on behalf of scientists conducting a variety of research on coastal erosion and developing strategies to counteract that. A book titled Science of the Total Environment contained a journal which looked into calculating overtopping discharges, which is a fancy way of saying determining the probability of waves given previous data. By tracking ocean activity, specifically looking at wave height and peak periods, they could estimate when seawalls would have to be revised through construction. By running multiple tests on a seawall in Europe, they concluded that 22 out of 36 of their trials indicated waves surpassing the European threshold for sea walls protecting people, indicating that the sea walls were ineffective in protecting these communities, given the height of the waves and the volume of the waves. Essentially, if we know when coastal protection needs to be developed and we have a general estimation of future wave activity, we're prepared. This study's conclusion is pretty similar to the next two sources I will talk about, as they all have the common theme of assessing current infrastructure and knowing when to replace it. A recent 2017 journal exploring natural hazards performed multiple risk assessment tests in Quebec, Canada, and determined that roads and municipal infrastructure were the types of land most vulnerable to flooding. Another journal on ocean and coastal management looked at sea level rise in Scarborough, Maine, and they mentioned that the US Route 1 marsh crossing, which is a highway, would cost $4.8 million to restructure for flooding damage. Now, this is expensive, but we must account for what would happen if we did not restructure these areas. This is a significant problem, as it would take time to perform constructions on these roadways, but if we were not looking ahead and moving accordingly, damages may stop whole entire communities from functioning. Roadways and land designed specifically for transportation are essential to keeping our modern society intact, and the damages of potential flooding stretch beyond coastal communities because of this. Let's say you're a package handler at UPS like me, and you have a supervisor that tells you what truck you need to sort boxes from. If your supervisor lives in a coastal community and cannot get to work due to flooded roads, you can't do your job, the people don't get their packages, and the companies are going to be annoyed at how inefficiently their products are being delivered. So this chain reaction could genuinely hurt the economy and seriously influence the stock market. If we allow this level of volatility in our economy, big businesses could shut down and all sorts of unemployment problems could occur. This isn't even taking into account the additional costs of restructuring after floods happen. If a multi-million-dollar seaside mansion was flooded, that alone may cost more than rebuilding the US Route 1 highway. I did some research on historical floods as well and their overall costs, and I learned about Thailand having copious rainfall that goes on for hundreds of days nonstop. So in 2011, the economy suffered expenses adding up to $45 billion. So now that $4.8 million for moving a highway doesn't seem so bad in comparison. The point of all this is that operations like risk assessment, cost calculations, and most importantly, estimating sea level rise and taking action beforehand are all anti-flooding measures that are necessary to keep our communities safe. Appreciate you for tuning in.